All right, hey folks, Mr. Miliano here, and we are going to introduce circular motion in this video. So here's the setup that we have. I've got this tumble buggy here, this cart. You can see it's connected to a rope, and that rope is tied off to this heavy ring stand here, so it's not gonna go anywhere. And if we turn the cart on, let's watch it move. All right, so there it goes. It's moving around in a circle right now as we go. Notice that we need the rope to make it move in a circle. We need a tension force toward the center of the circle. If we zoom into this buggy, we can see that the velocity arrow is always pointing forward, tangent to the circle, and the net force, that red arrow, is the tension pointing in toward the center of the circle. This is our key idea, that we need a net force toward the center of the circle, and that we need and then the velocity will be tangent to the circle. I'm gonna turn the video off real quick, or not the video, the cart off real quick, so that we can talk a little bit more about what's going on. So that's the key takeaway though. If you get nothing else out of this video, net force toward the center of the circle to make an object turn, and velocity tangent to that circle. Those two things. Now let's talk about reference frame choices with this. I've got handy here a bulk set of reference frames, XY axes, and it may be beneficial to choose an XY axis like this that we can see there. And then we let it turn some. And then maybe when it's 90 degrees later, we might start to see the problem with this choice in reference frame. When the cart was over here near the reference frame, its velocity was in the Y direction and its force was in the X direction. When it's turned 90 degrees, well, those roles have flipped now. We've got that same reference frame, just moved somewhere else. Now the force is in the negative Y and the velocity is in the positive X. Whereas 90 degrees earlier, velocity was positive Y, force was positive X. And then if we drive forward maybe less than 90 degrees, we can see that the force arrow's at an angle relative to my reference frame, and so is the velocity arrow. And so Cartesian coordinates, with X being horizontal and Y vertical, or X one direction and Y the other in this case, is not the best choice. Instead, we are going to grab a brand new reference frame, which I've got right here. We're going to choose a reference frame where one axis points in the radial direction. That means along the radius of the circle. And we'll choose another axis in the tangential direction, which means tangent to the circle. That T there does not mean time. It has a vector arrow above it because it's a position, and it's the position axis tangent to the circle in this case. And so once when we're right here, the tangent and the radius circle will line up. But when we are, this looks about 30 degrees later, we'll use the reference frame where the radius points directly along the axis of the tension there, and the velocity points directly along the axis that's tangent to the circle. We can see in this reference frame that the force points in toward the radial direction and the velocity points toward the tangential direction. If we zoom out, we can see that the X, Y coordinates are at an angle relative to that reference frame choice. So when things are moving in a circle, choose a reference frame that is helpful for the circle. Now this orange reference frame is not moving with the cart. It is off to the side at rest at that instant in time. But then if we have the cart moving around in a circle later on, we're going to choose a new radial and tangential direction that looks like this, where the radial direction still points toward the center of the circle and the tangential direction still points in the direction of the velocity. So this is the choice and reference frame for circular motion. And then we'll see that the force is in the radial direction and the velocity is tangent to that. All right, folks, that's our introduction to circular motion. Force in the radial direction toward the center of the circle, velocity in the tangential direction in the tangent to the circle. All right, there we go.